And all right, so the Pythagorean theorem. What does that have to do with circles, you say? So of course, Pythagorean theorem, you guys all know about that. But did you know the distance formula is just the Pythagorean theorem? Right? A squared plus b squared equals c squared. Here is c that has been square rooted, right? So if we square both sides to make this go away, now we have c squared. And a is just a length. We know that from geometry that the length can just be described also as the distance between 2 points. So if I just think about how far apart these x values are, it would also tell me the length of something. Length and distance are pretty much the same thing. So there'd be a squared and then plus b squared. So c squared equals a squared plus b squared. If I want to know how far apart these points are, the distance between them, the length of the line, length of that line and the distance between those 2 points is the same thing. I can break it down into the components of those 2 points, the x component, which we're choosing to call A, and the y component, which we're choosing to call B. So the distance can be described in those terms, which is just the Pythagorean theorem. Distance formula is just an application of the Pythagorean theorem. Okay? Well, not only that, we look at the equation of a circle, and this is called the center radius form. Kind of like we have like vertex form of a parabola, we have a slope intercept form for a line, right? This is called the center radius form of a circle. It's just some number squared plus some other number squared gives us some other number squared. That's just a squared plus b squared equals c squared. Okay? So what's happening here is that we talk about the center of that circle when we talk about its radius. Okay? Well, what's just happening here is that we're just spinning that radius around, and it's just giving us the equation for all these points, which is what a circle is. A circle is the collection of all the points that are the same distance from some other point, that all of these points out here are the same distance from the center. So, okay. So that's how we can actually see that Pythagorean theorem and the equation of a circle are related, interestingly enough. But just like slope-intercept form, guys, or just like vertex form for a quadratic, when you guys look at an equation in center radius form, you should be able to just pull out very important information about a circle, okay? I.e. its center and its radius. So if I were to tell you guys that the equation of the circle was x plus 1 squared plus y minus 5 squared equals 36, that you should be able to look at that and tell me what the center of that circle is and what the radius of that circle is. Okay? Just like so much of what we've seen over over our work with functions is that when the number is inside of the function like that, it lies to us about its sign. Right? H is always a liar to us, right? So this plus 1 is lying to us about its sign, because what it's really saying is x minus some number. What number are we subtracting from x? Well, we'd be subtracting negative 1. X minus negative 1 would be the same thing as x plus 1. Okay? So this is lying to us about its sign. So the x coordinate of the center is negative 1. Now, what number am I subtracting from y? I'm subtracting 5. So this is positive 5 here. So the center's at negative 1, 5. Remember, this says r squared. So this is not r. This is r squared. So the radius is 6. Yeah. So if I want to go and draw that circle, I can. If I want to grab that circle, I can with that information. Okay. So it's just about reading, pulling the information out. Just sitting there for you guys, just like slope-intercept, just like vertex form. It's just there waiting for you guys to see it. Okay. So in the same way, I should be able to give you guys that information. You guys should be able to write the equation. So if I said, hey, the center is 3, negative 2, and the radius is 4, you should be able to write the equation of that circle. Feel brave, Grant?
Sure.
Okay. What you got?
X minus 3 squared plus xy plus 2 squared equals
All right, jump. Okay, so make sure to switch the signs, make sure you square the radius, but the information is just there. You can see it. Okay. I'll throw a little kind of the wrinkly side at you, so you guys can deal with that. So what if instead we have so what would be our center? What would be our radius? What would be our center? What would be our radius? Claire's saying the center would be 0, -4. Okay. What about the radius? Feel free to give me the easy answer. All right. So center 0, -4. There's nothing with the x, so 0, right? What's being subtracted from the y? -4 is. We need to square root this to get the answer, right? But you guys should all know how to simplify this, to reduce this. Especially all you guys that I had, personally last year, for sure taught you this, and I know we've talked about it in this class also. How do we simplify or reduce radicals? Socket. Okay, there's multiple methods, but the method I personally teach you guys is the socket method. All right, so take that 2 out, 2 times 10, 2 times 5. Pairs of 2s, so that 2 gets to come out. 5 is lonely, stays inside. So the radius is 2 radical 5. I know I had somebody in first hour that was doing it the other method, which is more of the abstract, like thinking method. She was looking at the 20 saying, oh, 20 has 4 in it. So square root of 20 is equal to the square root of 4 times the square root of 5. And of course, the square root of 4 is 2. And 5 doesn't change. So that's called the product property method. It's a faster method. But it's more abstract. You're looking at that number and thinking, hey, what are the perfect squares that go into this? All right. So are you really good at knowing your perfect squares? Are you really good at looking at a number and seeing those perfect squares in that number? Right? And if you are, then you can do it faster. This is the more concrete way where you have to write it all out and get your answer. So, and teenagers tend to be more concrete thinkers than abstract thinkers. So maybe you're more comfortable with this, but again, this is the faster way to do it, but they both work. So sock method, product property method, reducing radicals. Okay. So those are kind of the wrinkles that you can see with an equation of a circle, right? Something's not there. What do you do with it? Don't have a nice perfect square. What do you do with it? Okay. That's about it. Let's do a little bit more of that, but just like in this chart form here. Maddie, what about that first one? What's our center?
0, 0.
0, 0. Okay. What's our radius?
4.
Oh, thank you. Piper, what about the second one?
Three.
3, 2. Okay.
2.
All right, thank you. Katie, how about third one? Good Lord, that's fast. All right. Yeah, x plus 2 squared plus y plus 1 squared equals 9. Switching signs, squaring the 3. This is a little wrinkly. You can do this one for me. X squared plus y minus 4 squared. And Claire's saying it's 2. Why is that 2, Claire? Okay, so we square the square root of 2, we get 2. Why does that happen? Why do we get 2 out of that? By they, you mean what? Right, yeah, not opposites, but inverses, yeah. Like squaring and square rooting are inverses, so those cancel each other, right? So you're just left with the 2. That's one way to think about it. Yep. Another way to think about it is, what does squaring a square root mean? Well, it means to take it by itself. Square root of 2 times the square root of 2 is square root of 4, which of course is 2. But either way, to be able to go to 2 quickly is the key, that we shouldn't have to be focusing too much on this, or especially not having to do all that math there. We don't want to spend time doing that. We should just see the answer. So we could say, the square root of 6 squared is what, Caleb? It's the square root of 6 squared. 6, right? And Tiger, what's the square root of 11 squared?
The square root of 11?
11 square root of 11 squared is?
Wait, oh, 11.
11, right. Yep, so we should be able to do it quickly. Okay. All right, last one. What's wrong with this last one? Yeah, we need to move that y over first, right? So take care of that, move the y over, and then it should look more normal. Right? So x plus 5 squared equals. So then adding y squared to both sides. It's 12, right? Where does that get us, Rhea? Say again? 2 squared to 3? Where'd you get 2 squared to 3 from? Start the square root of 12? Okay. So Rhea socked out the square root of 12 and got 2 square roots of 3. So a pair of 2's, only 3. All right. Thank you, Rhea. So all of this was just trying to get you guys to understand that when you look at the equation of a circle, like what are you seeing? Like how do we read it? We'll look at graphing them really quickly later. Okay. Before we head off to do anything else with that, I want to talk to you guys about how to graph this on a calculator. Okay. So when you guys think about hitting that graph button on your calculator, or the where you put the graphs in the functions in, right? It says y equals, right? And so what that means is if we have x squared plus y squared equals 16, we can't type that in to our calculator because it says y equals. It has to know what y is first before we can graph that. And so in order for us to graph a circle, we have to go through the process of solving for y. Right? And that's what they're kind of showing us here at the bottom of 114. But of course, when we square root, we have to deal with the fact that there's 2 answers to that, the positive answer and the negative answer to that expression now. And so that's what they're showing us here, is that we have 2 expressions that we're going to end up having to type into the calculator. Okay? But if we kind of think about what we're going to see when we do that, we have some familiarity with these graphs, like some. We've graphed square roots before. We know what those look like, that it's starts at 0, 0 usually, and then heads up and to the right. Well, that doesn't look like much of a circle, right? Well, that square here ends up making it turn back down. Okay? And then when we go to graph the upside down square root, right? So we start at 0, 0, and then we go this way. Oops. And then that square ends up getting it to turn, right? So what we end up doing is like graphing the top half of the circle and graph the bottom half of the circle. It can't graph it all at once, okay? So we end up having to graph it in halves. Okay? So let's go ahead and look at the calculator now. Let me unshare this thing. Share my screen. Let's go ahead and type in the two functions, right? The square root of x, square root of 16. Oops, that's not right. Square root. And if you have an older calculator where it's bringing the parentheses up right now, then just keep typing and you'll just close your parentheses at the end. If you have the newer calculator like this, where it's going to just draw the radical along with us, then just type away. So then minus, of course, your x button is right here, and squared. So right now you should be either closing the parentheses, or we can hit right to get it out of underneath there, which we don't really need to do this. Or we can just hit enter and it'll drop it down for us. And then we'll type in the next one. So then negative second square root 16 minus x squared. So there's our two functions, because a circle itself is not a function, but the two halves of a circle are functions. So those are two functions that we're going to graph. And I want you guys to go ahead and hit zoom 6, right? Get back to your normal 10 by 10 window. I don't know where your window was before. Let's just go ahead and hit zoom 6. Right? That's the standard window, the 10 by 10 window. And let's see what we see. What we see does not look much like a circle, right? So there's a couple things wrong here, and it really just comes down to limitations of the calculator itself. So obviously you can see the gaps in between the two halves, and that's purely like just a resolution issue, right? We have these little pixels that the calculator uses to make the graph for us, and this is like Nintendo version, right? Versus like your phone being the Xbox. Like the resolution on this is just really poor, so it just physically can't resolve what should be happening there. The math is there, just it can't draw the lines. The pixels don't work that way. Okay, so the gaps are just a pixel issue. Okay, now that's a football, right? Not a circle, and that's a shape issue, right? That if you look at your screen, guys, it's a rectangle. It's not a square, right? And so it's longer than it is tall, just like your TV. Okay. Well, what that means is that if it's 10 by 10, and 10 by 10, that the ones going sideways have to be longer than the ones going up, because they have further to go in the same amount of steps. Okay, so it's dragging the circle sideways with it as it does that. That's why the circle looks like this. Okay, so there is a way to fix that here. And so if you hit zoom 5, what that does is it changes the window shape. It changes the window bounds to make it more square. Okay, so you see it says z square. When you draw it, it'll look more circular than the other one. Okay, so that's why that z square is there, to deal with things like this. That basically what it does is it makes these gaps here vertically and here sideways the same size. And if you go and look at the window, you can see that the window now has these like kind of strange dimensions. Okay? But all that was just try to make those gaps the same size. So it actually is a square versus being a rectangle. Limitations of the device here. Okay, just so you guys can see that, how to work around some of it. And you just have to let go of the gap thing. That's never going to get cleared up, but you can make the shape look shapier. Right? Anything with that? So you guys want to talk about just how to graph on a calculator like that? This is nothing like you guys need to be stressing about. I'm not going to test you over this. That's really just me showing you how to do this.
Mr. Baker.
What's up?
My calculator is only showing me like the bottom half of the circle.
Okay. You for sure have both typed in.
Yeah.
Do you have, go back to your y equals. Is
Okay.
this equal sign black like this?
On one of them it is.
Yeah, so there's your problem. So what you need to do is go up to the one that's not. So I'm just hitting the arrows, and I can get it over onto that thing, and you want to enter. So I can turn mine off. Like I just turned mine off. So that first equation will not graph because that basically it's like it's not selected. So if I hit the graph button, it'll only graph the bottom.
I can only have one selected though.
That is definitely not normal. So you went and selected the other one, like the second one turned off?
Yeah.
Weird. You know what you need to do is you need to slap your calculator. And by that I mean you're going to reset it. So hit second memory. And then you're going to hit 7, which is the reset.
Mm-hmm.
And you're going to reset your defaults. That'll just should clear up any weird buttons that might have been hit, like while it's sitting in your backpack or your cat stepped on it or whatnot. Okay. Then it might have wiped this out. Nope, mine's still there. But I do notice that these are both turned off, so I have to go and turn them on. And I would try that. Would be the next thing I would try.
Okay, thank you.
You threaten it, and then usually it's like, okay, I'll do it. That's how you treat people, so yeah. That's what the president taught me. Chat. I just got too political. So I accidentally put a subtraction instead of a negative in the button graph. Like you got a subtraction sign here?
Yeah, like I did minus the square root of 16 minus x squared, and then it only graphed the top one, and then I just tried to change it to a negative sign, and then it let me graph it. It graphed
Yeah. Yeah, it definitely will not understand what that means. Like the calculator does not understand a minus. Like we see the minus and we can say, oh, okay, sometimes that's a negative, sometimes it's a subtraction. The calculator cannot tell the difference, so it has to have two different buttons. So when you put minus that, it's like, what are you subtracting it from, you crazy person? You have to subtract from something, and so it doesn't graph it. Yeah, it definitely would not do anything. So, yeah, did it throw an error at you? Did it do that to you, Victoria?
Yeah, it did.
So I think a lot of times, the little calculator trick guys, you might be, when it does tells you hey, something's wrong. I think too often our default is just to quit, stupid thing, quit, right? You actually really, really, really want to go 2. And so I hit 2, or I go down, I select that. It literally will take you to the spot and says, here's what I don't get. And it literally highlights it. And so it's highlighting the minus sign. It's like, I don't understand minus. This does not compute. Okay? And you're like, it's supposed to be a negative. Right? And you switch it, and remember the negative and the minus are just slightly different sizes. And then we fix that, you should be all good to go, just like you said. So yeah, don't quit on the errors. It will try to talk to you and say, here's what I don't get. Fix this so I can do do the work. It wants to do the work. It's confused. We can try to talk in a little bit, Maddie, then if you're still having trouble, but to see if we can troubleshoot yours. But okay. Interesting things. Why is my camera off? Weird. Well. Okay. That's that. So the real reason we're talking about this, right? So we can do this. Now, when we look at those two equations, we know what those equations are. They're the equations of a circle and the equation of another circle, right? But we want to solve this system, right? So which method should we use, right? So if we're going to use substitution method, what do we want? What's them do? Why can't them? Yeah. Yeah, we want one of the variables by itself, right? So we want to get one of the variables or have one of the variables by itself. And so just like we talked about on Monday, Grant, is getting X or Y in either of the equations going to be something that's easy? No, why not? What's it going to involve that's going to make it not easy for everything, right? So if we're going to get X or Y by itself, and hopefully noticing that this would probably be the easier of the two, if we just said, hey, let's get X by itself. So we subtract Y squared over, okay, easy peasy. Then we go and we square root. Now we have this expression with a square root in it, which is like, not the easiest thing to deal with. So mathematically possible, just not easy, right? So then we say, well, what about elimination? What do we want when we go to do an elimination problem? What do we want to see? We want opposite signs or really opposite coefficients, right? So we want one positive x and one negative x, or we want one positive 5x and one negative 5x, right? So we want opposite coefficients. So Claire, is that something we could make happen easily? Yeah. So, kind of just think about what's the easiest thing to do here. Claire's saying, yeah, we can just multiply one of the equations by -1, right? So is there one of the equations that would look even, you're saying one of them, is there one that you would want to do versus the other? Yeah, top one would be a little easier, right? Just so we don't have to deal with that set of parentheses there. So we're going to multiply everything there by -1. Just make sure you're being really good about your distribution. I'll bring that all the way to the right side of the graph just so I have space to work. So I got negative x squared minus y squared equals -100. And let's bring the other equation over. And then once we have them opposites, right, we're just supposed to add, right? So we can just add these together. So of course, the whole point was to get those x's to cancel, and so there they go, they're gone. Now I have negative y squared plus y minus 5 squared. I'm going to just turn that around just so it looks nicer to my face. That's all I'm doing here. Okay, so I'm going to write the y minus 5 squared minus y squared. Okay, if I write the other way, go for it. It doesn't change anything. I just don't like it. And then negative 100 plus 25, of course, is negative 75. Okay. So goal accomplished, right? X is gone. One equation, one variable. We're moving on, right? Moving along here. We really need that left side to be simpler. When I look at that and say, well, what's complex about it? I look at this thing and say, I need to do something with this. So y minus 5 squared. What can we do with that? What do you mean by that? Okay, so how's that look? Just dropping that in. So Claire said just drop the square in. I'm going to give her the eyebrow of about that. What does it mean to square something, Claire? So yeah, y minus 5 times y minus 5. All right, really, really common mistake. Somebody said that in every hour. Okay, we just forget. Right, you have to do it this way, or else the math goes bad. Right, so it pops up and pops up and pops up. When you go through the distribution, you should get here y squared minus 10y plus 25. Right. So, I'm hoping somebody that's what that beep on the chat was. Yeah, right, Victoria. So go through the FOIL, go through distribution, right? Hopefully you guys noticed that the y squareds are just going to cancel. That makes everything super easy. So I get negative 10y plus 25 equals negative 75. You put a little effort in there, you should get y equals 10. So now we know y is 10. What's next? Now we're done. Y is 10. We're done. Now what? Graph it. Why are we plugging it back in? Find x. Yeah, we need to find x, right? Need x and y. So plug it back in. We're going to plug it back in, right? First one? Good. Doesn't matter? No? Okay. So it's plugging it back in. Ray wants to do it in the first one. So we get x squared plus y squared, which of course is 10 squared, equals 100. So what do we add to 10 squared to get 100? What are we adding to 10 squared and getting 100? 0, right? That's got to be 0. So x squared is 0. X must be 0. X is 0. You see that happens over here too. We make this 10. 10 minus 5 is 5. 5 squared is 25. What would I add to 25 to get 25? I would add 0. 25, right? Doesn't matter which one you do, but we get 0 and 10. Remember, this is a point. 0, 10, right? Monday we talked about the point where the lines cross. Well, these aren't lines, these are two circles. Okay? So what it's saying is that these two circles will touch up here at 0, 10. Now, I want to quickly talk about, oops, that's not what happened. There's only maybe two ways that two circles could touch at one point. Okay? And a word you guys should recognize, it's been a while, from geometry, is the word tangent. Okay? And there's multiple math definitions of tangent. So there's the sine, cosine, tangent, which is trig stuff. But then there's the actual physical geometry side of things. When we talk about a line being tangent to a shape, so if a line is tangent to a circle, that line just touches that circle at one point. So that line would be tangent to that circle. And when we use the phrase I went off on a tangent, this is really what it refers to, is that if we're supposed to be following a certain path and then we kind of shoot off of it, that's what it means to go off on a tangent. Okay? So we're supposed to be talking about one thing, but then we get distracted and start talking about something else. We go off on a tangent. And well, if two circles are tangent, they could touch at one point. Okay? Or it could look like this and touch at one point. Okay? So there's ways, but those are about the only two ways you could have two circles and touch at one point. You have to be right next to each other some way, or one's inside of the other, but smaller, just touching at one point. Okay, so we're seeing that it's saying one intersection. So we're gonna end up some arrangement like this. Okay, there are other ways for circles to touch. So if I have two circles, they could also touch at 2 points. Or they could touch at every point. Or they could not touch at all. Right? So if what we're talking about is two circles, they can either touch once, twice, all the time, or never. So with lines, we saw once, all the time, or never. But with two circles, we have another option. Okay? So just FYI, if you're graphing a system of, or if you're solving a system of two circles, there's 4 possible outcomes. 1 answer, 2 answers, infinite answers, or no answers. Okay? Well, we see 1 answer. Right? So how do we graph a circle by hand? This is kind of fun. You guys don't need to stress about this. It's not. I'm going to show you how to do it on the computer. I just want to do this just for fun, really. How do we graph a circle by hand? You need to go and look at that equation, see what it's telling us. So looking at that first equation, you should be able to read its center and its radius just by looking at it. Well, there's nothing with the x, there's nothing with the y, so my center must be at 0, 0. And then 100, I need to square root that, so my radius must be 10. So I'm going to draw a circle with the center at 0, 0, and the radius at 10. How do I do that? So my center is here at 0, 0, right? Origin. Remember I said earlier about like what a circle is. It's the points. It's the set of all the points that are 10 or some set distance away from another point. I want to draw all the points that are 10 units away from that point. Okay? Well, the easiest thing for us to do on a graph is to move left and right and up and down. I can move 10 very easily to the right. So I'd be over here at 10. I can move 10 very easily to the left. I can move 10 very easily down. I can move 10 very easily up. It's hard for me to know where 10 is out here. Don't expect you guys to know that. Okay? Once you have those 4 points, you just do your best to draw a circle. That's all it is. Okay? So I do it by quarters. I just try to draw a circle through the quarter. That's all I'm doing. Okay? Don't expect magic. Okay? Feel like I'm doing a poor job. My circle last hour was lovely. Just let you guys know that, it's not looking great. I'll do a little better on this bottom part. That's much better. Top half of my circle kind of looks like that guy from the Goonies. A little pointy. There's my circle with radius 10. What about the next one? What's the center with radius? 0, 5. Ooh, that's not right. All right, thanks, Grant. 0, 5, radius 5. All right, so go to 0, 5 right here on the y-axis. Go right 5, down 5, left 5, up 5. Ooh, look at that. There's 10, 0. There they are touching, right? Just like we said they would. Okay, and then just do your best to draw that circle that goes through those points there. Okay. Oh, not too bad. Pretty happy with that one. There's some little like game you can play online where you have to try to draw a circle as best you can, and it judges your circle with math, complex math thing, like how round is it, how fast did you do it, how many points, and it gives you a score, and then try to get the highest score. Be with your friends. Good times. So what I want you guys to do though, okay, so obviously I want you to solve it with your brains and algebraically, okay, but I don't want you to check it like this. I want you to, if you want to check it, just go ahead and check it on Desmos. It's super fast, it's super easy. Don't use your calculator. Okay, Desmos works so much better on this. The programming behind Desmos is just more robust. So you can see I've already typed in the two equations here. And especially because Desmos can handle X and Y on the same side. So I'll turn that on and I'll turn that on. So we can see the two circles, and we can see that they've touched right there. So it's all super simple. So if you want to check your answers, feel free to do it on Desmos. But obviously I want you solving it on your own. But okay. Yeah, just if you want to check it, do it this way. Okay. Or you could always just plug it back in. I mean, these are not hard to check that way either. But I think it's kind of fun to see the shapes and how they're interacting. So let's do that last one real quick, and then that's not right. Okay. All right. And then we'll switch my screen. So we want to use substitution, or we want to use elimination to graph that. Hey.
Hey, sorry about me again.
What's up?
I realized I won't be here around 7 period.
Okay.
Better time.
Is tomorrow fine?
Yeah, tomorrow will be good if you're okay with that.
Oh yeah, fine. Cool. Thanks, James. What do you think, guys? Substitution, elimination? What's this person say? Madeline says substitution. Why are you saying that, Madeline? What do you see?
Because it has like a variable that's equal to something.
Yeah, right. This is like the perfect substitution problem. It says y equals something, that then it says y equals something else. Like, this is ideal for substitution. Because if y is equal to x squared minus 2, that means we can take x squared minus 2 and just put it over here. It's lagging again. Okay. So that just means that x squared minus 2 is equal to negative x plus 4. And going back to geometry again, the transitive property says that when you guys were doing proofs, that if A is equal to B and A is also equal to C, then B and C must be equal to each other. So here they are equal to each other. It's being super laggy there. So, and we should be able to solve that equation quickly. I would sit here and wait for you guys to do it yourselves, but we're running out of time. So I see a square, I see an x. We need to get everything to one side so we can factor. Okay, so move everything to the left side. So x squared plus x, and then subtracting 4 over gives me minus 6. Last hour I added it over, that screwed everything up. And then we want to AC that, so that's our factors of negative 6 add to be 1, which would be positive 3 and negative 2. So of course x would be negative 3 and x would be positive 2, eventually. Oh, we got 2 x's. We need to plug them both back in. We're going to get 2 y's because we're going to get 2 points of intersection. So, doesn't matter which equation you use. I'm going to use the top one. So negative 3 squared is 9 eventually here. So I'm pointing at negative 3 squared is 9. 9 minus 2 is 7. So when I plug in negative 3, I get 7 for y. So negative 3, 7 is my point. And then I plug in 2. Wait for it to catch up to me. 2 squared is 4. 4 minus 2 is 2. So I plug in 2, I get 2. So y equals 2. So the point must be 2, 2. We didn't talk about what this was. We're going to time this, but this is a parabola. X squared minus 2, that's a parabola. Second one's a line. It's just a line crossing a parabola. Yeah, if we look at Desmos Toot Suite, see really quickly that it is just a line crossing a parabola. Let me share again real quickly, guys. Okay. So you guys can see that, and then you can see that the negative 3, 7 and 2, 2 are intersection points. So we did a good job. Okay. Nice hearing from you guys today. Good job, guys. I'll see you tomorrow.
Thank you.
See you, Ruth.